Hello everyone, I'm Shraddha. I'm excited to take you on a journey where we'll be talking about how confusing spikes are converted to AI augmented stories, which helped our customer troubleshoot faster and it helped them in their day to day life. So, let's consider you want to play some music. You're trying to stream your favorite playlist on Spotify, but it's keep buffering, or the worst, it's not loading. Now, where is the issue? Is the issue in your Wi-Fi, or is the issue with the internet service provider, or the issue with the cloud provider where the Spotify is hosted, or the issue is in between the network transit? And that's where the Thousand Eyes steps in. Thousand Eyes provides the path trace throughout your digital experience. So consider going from your own application server to internet service provider, and towards the cloud platform and the backbone of the whole internet. So Thousand Eyes sees the whole internet backbone. uh, that being said, uh, now consider if you want to understand what's going wrong with the Spotify. What if we have an AI agent that explains the issue, even if it's not in your network? And that's where we say like Thousand Eyes provides the visibility and AI powered insurance across your owned and unowned environments. Now, that being said, with Thousand Eyes, we have very rich telemetry data across application and network metrics. So we have these great visual dashboards where we have a lot more data insights related to network application layers. Now, consider looking at this dashboard. Imagine if we can convert these standard dashboards, moving from these standard dashboards to a AI augmented stories, which will help users troubleshoot the issues faster. So let me take you through an example. So there was a Google Cloud outage happened last month on 12th June, and the Spotify was hosted on the Google Cloud. So you're listening to the music, and user complaining about low availability about the Spotify. Now, as a user, if I have to troubleshoot this issue, as a Thousand Eyes user, I have to click through these multiple layers like HTTP layer or network layer, or BGP routing layer where the how the packets are routed, and even I have to click through n number of metrics to understand and piece together where is the exact issue coming from. Like the issue is at the application, that is the web layer, or is the issue with the network layer. So we have this in number like good visuals and the dashboard, and user has to click through this n number of clicks to understand and come up with the fault domain assessment. Now, that being said, these are the key pain points we observe. Like there is a cognitive overload when we are trying to troubleshoot. Like it's very hard to isolate to fault domain where the exact issue is, and oftentimes there is a contextual amnesia. Like the context is lost during the investigation, and sometimes folks who are not very expert in the network ops, they find it very difficult to interpret this views data. And that's where we deployed our AI agent, where with a single click, you can get the insights happening across all these layers, which correlates the data and provide a great insights. So as I click on this explain button, the AI assistant is coming up, and now it's connecting to the model, and now it's going through each layer by layer data and trying to give me a fault domain analysis. So here we can say the Spotify was not working fine because there was issue at the HTTP layer. That means the application layer was impacted with where we have less availability compared to the baseline data, and multiple agents. That means multiple locations were impacted. Here we can see in the map multiple agents were impacted with different phases, like the receiver HTTP phase. We can see there are different this error codes. So when we click on this button, the AI agent comes up. It goes through this investigation. It tries to piece together all these layered metrics and correlate the data and provide a impactful fault domain assessment. And this is helping our customer to troubleshoot faster and go towards the final leg where they are trying to find the issue. Now, user can also click on the follow prompts to get more understanding about specific layer. Okay, what's happening in this specific layer and so on. So that being said, now what we have seen, so this is where with the AI agent in production, we are trying to shift from data presentation to the intelligent interpretation mode, where we can faster have troubleshooting and fault isolation performed. And how it is impacting the customer, where we are trying to improve the mean time to resolution and mean time to market. And in this, through AI agent, we are trying to capture the key observations across these layers like HTTP network and package data. Now, how are we deploying this AI agent in the productions? So when I clicked on the explain this button, the AI assistant pop-up came up. Now it routes the request through a semantic kernel. So it's the open source framework used by Microsoft. And then that semantic kernel is routing the a request to our views agent. And now views agent underneath makes a call to the LLM model uh, and provide the data and get the response back and display the response on the AI assistant. So in this quick architecture diagram, we can see like it goes to the views agent, it makes a call to our API endpoints, and before providing the response, like hitting the call to the LLM agent, we do a lot of pre-processing and we get the response from the LLM agent. And for the faster explanations, we are also storing the chat history. Now, the key part, how we are implementing this agentic behavioral in our agents. And we really use different techniques to come up with the prompts. So the model which we are using for this is Anthropic Claude 3.7 Sonnet model, which is a good reasoning model. And we use different techniques for the prompting, like role prompting. We are assigning a role, like consider you are a network engineer going through the solving these scenarios. We really invested some time understanding how we can employ the chain of thought reasoning, which gives the domain expertise while resolving the step by step analysis. We worked very closely with solution analysts or subject matter experts who helped us form this chain of thought prompt reasoning. We also included some few short prompting where we demonstrated how should the input and output look like. For example, to give the full domain analysis, like user should be able to click on the links very quickly, and what should be the response structure you should adhere to. So these were the few prompt related techniques which helped us. And uh, how now the main part, like how did we evaluate the response of our prompts and overall the evaluate the AI agents. So here, as to start with, we started having the manual evaluations done. So we worked with our subject matter experts. We got the some ground truth responses from them, where we can see like the Spotify, there was a well-known outage. So we had the whole blog analysis done. So we used that data. We ran our POC with the agents, and that served as a ground truth data. So we have a human in feedback loop to evaluate the responses. Now we have also employed the LLM as judge to track different metrics like what is the hallucination rate, or how we can capture the answer relevancy, or the prompt alignment, or the data being fed to the LLM is right, and it's adhering to that overall matrix. Now, another part is to come up with the right LLM output structure. We followed some standard guidelines from the Anthropic model, where we got figured out the good response when we use the XML tags like instructions or examples and output format. We also made sure to guide the structure with a JSON schema to provide it into our system prompt, which really helped LLM to understand what kind of data is coming in. And in the previous panel discussion, we discussed like fast API or pydantic model. That's where we also embedded the data model annotations, which really helped LLM to understand the data model and learn more about what are the fields being injected into the LLM model. That being said, this was the overall strategy used to perform the prompt engineering. Yes, there were few challenges we observed with specific to our scenario. Being as you saw, we have wide variety of telemetry data across application and network, and that's where we have a sheer volume of data and complexity. So we had to do lot more of pre-processing enrichment on top of it in order to LLM guide better results. And we have these different metrics like HTTP related timing KPIs or latency. So we had to look into the broader concept of baselining those data or use some predefined strategies before we provide data to the LLM. And yes, if we provide the raw API data as is to LLM, there were few issues leading to high token counts and weak correlations. So we had to pre-process and enrich data in a certain format. Yeah, and very quickly talking about the next steps, we are employing how we can have a continuous learning or human in feedback loop incorporated with ground truth data with the outages data and the subject matter review. And currently we are using the Anthropic model, but going forward for these AI agents, how we can fine tune the model based on our network data and provide more training data and fine tune the model and host that model within our environment. Thank you.
Excellent. Thank you so much. And there's some super practical tips to take away from this. I really appreciate this talk. We are closing in though. Shraddha, I'm gonna keep it moving, and if anybody has any questions for you, I'll let them direct it to the chat or to hit you up on LinkedIn so we can keep the conversation going.
Sounds good. Thank you.